My name is Michael Roig, and today I would like to introduce our new tester, the Profitest H+E cable for testing charging cables. As you can see, here is a brief overview. You have the option to test Mode 2 charging cables and Mode 3 charging cables. Otherwise, a standard mains connection, the world of communication, a USB keyboard. But you also have the option to work with a barcode reader or a QR code reader, and an integrated printer, the ability to immediately generate a paper report. Otherwise, when you turn on the tester, you immediately have two options. In the database, you select either the appropriate Mode 2 or Mode 3 charging cable for testing. But before you do that, I would recommend that you go to the Settings menu. Because in the end, you want to have a report, and on this report, you will find all the information that you have already entered. That means when and on which day you performed the test. Who performed the test? In this case, I am entering my name. You can enter the company data. In this case, of course, our company, Gaussian Metrowatt. But you also have the option to create a backup. This means that all the data you have saved can be read out via a USB stick. You have the option to work not only in German-speaking areas, but also internationally, because here you can also select English as the language, so that you could also work in the UK. If you go to delete, you have to be a bit careful. Here you have three options. Either you delete all test reports, you delete the company data, or you go back to the factory settings, so that you have the tester back in its original state. Under the menu Test Reports, you will find all the information that you have already tested. If we go there, we see that these charging cables have already been tested. So, and the individual test, that is something very special, specifically for qualified electricians. If we get an error message or locate an error ourselves, you have the option to carry out the tests here in the individual test. That means low resistance continuity of the protective conductor insulation, RCD test, 6 mA test, so checking the sensors, or also the individual statuses, status A, B, C, and E. So if you go further down in the menu, then you have the option here again to call up the manufacturer database, to call up the calibration date, or also the current firmware that we have on it. So now we go back out, now we want to test. I have prepared something. We take a charging cable, Mode 2, from the company Mennekes. You will find all the information on the back of the charging cable. That is important. But it is not quite so bad. We have prepared something for you. The advantage of this tester is simply that we have stored all the manufacturer's specifications for you. This means if you can't find a cable, just let us know and then you can download it yourself. Because the database is stored with us in my GMC, you have the option to update the database yourself or give us the opportunity to add the missing cable. So we have a charging cable here, Mode 2. Now let's click on it. We see that the database is actually filled with quite a few manufacturers. We'll go to Mennekes. Now all the information appears that we would also see on the back. And we see that this is the number we find down here on the back. Charging cable from Mennekes. Now you have options to either assign the matching license plate or maybe even the VIN. Or you can choose an inventory number depending on what you need. What you enter here is simply important. It will appear at the end on the test report. So, first you do as always when performing a test. A test consists of visual inspection, testing, measuring, and logging. We'll start with the visual inspection. We have already listed all the important points for you in a brief overview. If you go through here, you can already see all the points that are important. Strain relief, power cord, important point, damage, labeling, no improper modification, as the case may be. If you select a point here as not okay, you can no longer start the test because the visual inspection is one of the most important there is. When you're finished, you have confirmed the visual inspection and we'll go into the start measurement mode. Now the advantage is that after you've selected the right charging cable in the database, the manufacturer data is stored for you. That means in this case, we would have a sensor system, 6 milliamps, we have a switching protective earth, so there's the possibility to measure here with 3 milliamps. This is automatically specified for the charging cable. That is important. Of course, it's also important when measuring low resistance continuity and insulation that you move the charging cable. because it could well be that a wire is broken here. And we also see here with which input voltage we perform the insulation test on the input and output sides. From this, you can often tell if we have an integrated surge arrestor, if we have electronics that might not be sufficient for a 500-volt test because we won't reach the limits, or if we even have completely different limits at 250 volts due to the built-in electronics. We see that we have 14 test steps here. This means we go through all the test steps one by one. This takes a while. In this case, we have the insulation test here. And during the insulation test, it's always de-energized. That means the charging cable is de-energized, otherwise you'd see it. And we can clearly see the corresponding voltage on the input and output sides, and also where the current test is taking place. So now you might be wondering, how long does such a test of a charging cable take? That depends, of course, which charging cable we're testing, how the charging cable is constructed, what's integrated. And depending on that, based on the manufacturer's specifications, we've defined the test cycle or the test sequence for you. So now we have here, we're testing the internal RCD, which means we also have personal protection in there, a functional test. In this case, we're testing the AC side with 30 milliamps, and as you can see, the advantage is that you no longer have to remove the cable after every test or after every RCD tripped. That means if you test the whole thing manually, it's quite possible, depending on the cable, that you'd have to disconnect the input side, meaning the main side, or even the vehicle side. And only then you can put the cable back into operation and restart the measurement. That's not the case here. It's done automatically. You can see it clearly. The test sequence after the charging cable or the internal RCD has tripped is simply that it's switched to de-energized again, and then the process starts from the beginning. And that's how we can perform every test step by step. And you see, after the RCD test, the sensor system is up for testing. An important point. And now we can test the 6 milliamps here. And then you'll ask, why is a 6 milliamp test important? A 6 milliamp test is important because we might have a type A installed in the house system. And if I have a type A integrated, then it would go into saturation with DC fault currents greater than 6 milliamps. That means it would become blind. So here, it's absolutely important that if DC fault currents were to occur during the charging process, we ensure that the user is properly protected. And that's done by the 6 milliamp sensor system. And we naturally have to test that it also switches off in time. And there are different sensor systems. There's an RDC, there's an RCMB, a CCID, there are many things. Ultimately, it's important that we know what's installed so that we can, of course, include the manufacturer's specifications in the test sequence. So once the 6 milliamps have been tested, we still have the functional test to do. Functional testing is very important. We know there are different statuses in the charging process. There is status A, which means plugged in. Here we have the 12 volts. There is a status B, which means it is locked. This means you cannot pull out the charging cable during the charging process anymore. In this case, that would be plus 9 volts, minus 12 volts, and 1 kilohertz. We have status C. Status C is then ready for operation, meaning it is switched through and charging can take place. In this case, we have 6 volts, minus 12 volts, 1 kilohertz. And in the event of a fault, if we were to have a short circuit during the charging process between CP and PE, then the charging process must abort. And we simulate that too. After status C, we do the whole thing in status E. And you can see it here again on the charging cable. It is constantly being switched off and on. The process is restarted. The short circuit is generated, like here. You see immediately, error message, switch off. So everything is working. And that will then be reviewed later in the report. So we still have one open point, which is leakage currents. Leakage currents can also occur. And that is what we do here. We check the residual currents. We can do that. We have a small internal coil. No problem at all. It is important that these are below the limit value. So those will then also be documented. Now you might ask yourself, what can happen if we trip the RCD here during the whole process? We also have the case connected to a circuit that has an integrated RCD. Could it happen that this RCD might also trip? No, it cannot. We have ensured that we have a small transformer on the input side, so you can be sure that the ongoing process in the workshop cannot be interrupted. Also a huge advantage in terms of safety. So we are now at the end. The question often arises, how long can such a test take? Well, between 5 and 6 minutes, if it is quick. At most, depending of course on the cable, the setup, the internal electronics, sometimes longer. So now we see the test is passed. We have a green check mark. If a red cross were to appear now, the test would be out of tolerance. Now we can save the whole thing. Now we have saved everything. Now there is the possibility to look at the values. So now we have done it. Who tested it? I tested it, Michael Roig. Then comes the charging cable. I wrote in this additional text marker here, we just had it as a test. We have all the options here, such as RPE, 3 milliamps, everything that's been tested. Just scroll through here. All the statuses that you see. So now there are two options. Either we save the whole thing. Then we'd have it all in our overview, of course. Or if we go to the measurement here, then we have the option to print it all out. So on the printout, everything that we entered at the beginning appears. Everything passed. There's also the option to print the whole thing with measured values. That means you know exactly continuity or low resistance continuity of the protective conductor, how high the resistance was, how high the insulation was, when the trip time was, trip current, everything is documented. At the end, please sign once, and then the test would already be finished. So that's it for this short product presentation. I wish you much success with the testing. It's the same for charging Mode 3 for the Mode 3 charging cable. Here too, the database, you pick out your suitable cable. It doesn't matter which, start the process from the beginning and can of course test the Mode 3 charging cable in the same order I just told you. So then I thank you for your attention and wish you much success with the testing. Thank you.